Alright, let's talk about vector fields for a second.
Variable that made it like
So,
longer.
a vector field is what? You guys know an example of this? Maybe a couple. Yeah, like
Just like a graph full of slope fields.
some kind of picture with like lines on it or something.
What the?
Yeah, like slope fields.
I
Yeah.
know, but.
What do you represent? Like, what is this? What's the point? Why would you talk about it?
Because there's infinite possible ways.
What do you want to talk about? Like, yeah, you want to talk about directions and magnitudes, right?
Yeah.
So, what's this thing do? What's it good for?
Changing direction.
How about modeling fluid flow?
Say like a wind tunnel or something.
Yeah. We think about this when we look at a wind tunnel, right? We think about where the when a fluid is flowing and how fast, right? You guys see that? So really all this thing is, right, is what? What do I mean by this thing?
Family of function. Or represents a family of
Okay, I think it's definitely a function.
like almost like gradients and stuff.
Oh yeah, gradients are a perfect example of a function like this. What do they take? Yeah, gradient takes a point in R2, for instance, and turns it into a,
R3. R turned into R2.
yeah, it turns it into an R2 vector, right? So I take a point, and at each point I'm going to draw a little vector. You guys see that? So this is a 2D vector field. What would a 3D vector field be?
Then from R3 and then an R3 vector.
Yeah, perfect. Takes a point in 3 dimensions and turns it into a three-dimensional vector. Cool. Examples? Okay. You guys have already said that gradient of f is an example. You guys give me a function that has a gradient that's a 2 vector field?
2x plus 2y.
Sure. Okay, so if f is 2x plus 2y, then gradient of f is
2i plus 2j.
perfect, the vector 2, 2, right? And really maybe I should add to this, the gradient of f has a function of x and y, right? It's 2, 2. Could we draw a picture of that one? Yeah, this one's really boring, right? Because no matter what point you give it, what's it give you back? 2, 2, right? So if I give it 0, 0, it gives me the vector 2 over 2 up.
2.
If I give it this point over here, what's it going to give me? 2 over 2 up. If I give it this point back over here, what's it going to give me? 2 over 2 up. 2 over 2 up. So this thing looks like constant flow, right? Cool. Everything's just kind of moving up in that direction.
Yeah.
Cool. Better one? More interesting one? How about f of x and y is, what's your favorite 2-dimensional function?
X squared plus y squared.
Good answer, Alan. Thank you. X squared plus y squared. Always. Favorite function. What's the gradient of this thing? 2x plus 2y. Right? Right?
Yes.
Yeah.
Well,
No!
I and J.
Oh, no.
I and J, right? Okay, so if I try to draw this thing, what do I get? Yeah, it varies, right? At 0, 0, where does this go?
0.
Nowhere. Okay, there's the arrow for that one.
There's something there.
Yeah, there's a 0 vector there. Okay, how about, where else?
Go to 1, 1.
1, 1?
Two,
Up
two.
here. Okay, the 1, 1, 1, 1's vector is 2, 2, right? Okay, how about down here at 1, 0?
That would just be 2. Going
Two?
straight up.
Going
No, that's
straight-
straight over.
Over, I think.
Out from.
So
Yeah, these all point out from the origin, right?
zero,
Why?
The max is 0.
Gradient of the circle is always
Alright, yeah.
out.
Yeah, this is, right, the gradient of a bowl, right?
Zero's the max.
So it's pointing steepest uphill possible direction, right? Which of course is straight away from the origin for a nice symmetrical bowl. You guys see that?
Yeah.
Okay, so. What if I went out further?
They're just getting longer.
Yeah, it'll get longer, right?
Mhm.
So if I went out over here, it's gonna point straight away, but it's gonna be a really nice long vector. Why?
So it's more steep.
Yeah, it's steeper there, right? And the gradient's magnitude, right, is how steep. Cool?